In this video, we're working in Chapter 6, Section 1. We're working on finding areas under the normal curve. And in particular, we're going to be working with the standard normal, which has a mean of 0 and a standard deviation of 1. All right, so I'm just going to look at the problem, the first problem in the notes, put it on the whiteboard, and then we're going to have to look for those formula cards to get them to work. Okay, so what we are going to do is note that we're going to be looking for an area to the left. I'm just drawing a picture of it here. So you know some z-score and you're looking for an area to the left, all right? There are 3 ways these problems show up as left tail problems. We'll leave this here for right now. Could be a right tail problem, or it could be a bounded region. Okay, and so we're going to go through all 3 of them and how to use the table to calculate what's the strategy for getting areas to the left, to the right, or between a bounded region, inside a bounded region for the standard normal curve. Okay, so let's look at the first problem, and the first problem says find the area to the left of 1.23. So we work in this class, we have some pretty standardized ways of drawing the normal problem. So I'd like you to draw the picture of the problem in the same way. And that way within our class, when I draw a picture, you'll know what it means. And when you draw a picture, I'll know what it means. And there'll be points associated and sort of to encourage us to work within those, that way of drawing the pictures for the normal curve. So first thing we're going to do is we're going to have a curve. And then at the top, a variable name. Our variable in 6.2 is always called z because it's standard normal. But in 6.3, we will work with general normal random variables, and those variables we will call x. But this is z, and z has always a mean of 0 and a standard deviation of 1. Okay, so the problem asks to find the area to the left of z equals 1.23. So we'll go ahead and draw the limiting value, 1.23, and shade the area to the left. Okay. So when we draw these pictures, we always put our z-scores at the bottom. So, and then areas are associated at top with arrows coming down. So we all kind of draw the same picture. Okay, so this is what we want. That's a picture of the problem. I'm going to come on over and look at our formula card for a second. So I'll share my screen. And this is a formula card. When you open it up, it will likely look more like this, right? And there are our formulas, and if you scroll down, then you get to that page we were with the normal curve here. So I'm going to go to view, rotate view clockwise. All right, and so I see here that we have a table. There are z-score. These inside the table is tabulated what's shaded here. So what's shaded here are left tails. So we have left, so this table is a table of left tails. If we have a negative z-score, we'll use the left-hand side of the table. If we have a positive z-score, we'll use the right-hand side of the table. To determine what row we want to be on, we're going to look at the units and tenths digits, the first 2 digits. So in the case of our problem on the board, that's going to be 1.2. Okay, and so we're going to go to the row defined by 1.2, and then we're going to go to the column, which is given by the hundredths value. So we're looking for 1.23. So we look at the 03 column, and we get this value right here, 0.8907. Okay, so let's go back to the whiteboard and we'll finish the problem up there. Okay, so we went into the table, we looked at note 1.23 is 1.2 plus 0.03. This gives us our column, this gives us our row. And we found out when we looked in that row in that column, 0.8907 is the area to the left of the delimiting value. So we're using the table, we use the table directly, we open the table, we look at the row and column, and we read the number out from the middle, we'll call, from the tabulated values. We will call that a direct lookup. So for this kind of problem, we do one direct. Okay, all right, let's go to the next kind of problem. And the next kind of problem is to find the area to the right of a specified value, and we are asked to find the area to the right of 0.76. Okay, so let's draw a picture of that. So this is a right tail, area of a right tail, so it's that second kind of problem. And again, we are working with a normal curve, standard 0, 1 parameters. 0.76 is my delimiting value, and we're looking for a right tail. Okay, so my problem is set up. It's just how I want it to be on the whiteboard. So now I need to think about what row and what column, well, when we get to it, we'll go to the row 0.7 in the column 06. But before we go there, we have to think about how we are going to get the area of a right tail when our tables are left-tailed, okay? So what I want you to notice is that the area under the whole curve, because it's a probability distribution, is 1. So the area under the entire curve is 1. And my table will give us, and the Z table will give us left tail areas, but I don't want a left tail, I want a right tail. So I'm going to use those two pieces of information together to find a strategy to get a right tail area. So the area to the right of 0.76 is equal to the entire curve minus the area to the left of 0.76. Okay, so that is to say, this is 1 minus whatever we get when we do this direct lookup. So we're not going to draw the double curves all the time, but I wanted to have them on there for now. I'm going to go to the formula card, if you will, as well, and look for the value, the tabled value for 0.76. Okay, so 0.7, it's positive, so it's on the right-hand side. The row is 0.7, and I'm going to go over to the column indicated by 06. So it looks like I'm getting 0.7764. That agrees with the notes, so that's a good thing. Okay, so this is going to be 0. Remember, that's the left tail. So my right tail is 1 minus 0.7764. Okay, and usually when I see the right tail, I can just say 1 minus the direct lookup. And that is equal to 0.2236. Okay, so if you need to calculate the area of a right tail, it's 1 minus the direct lookup. Its direct lookup is the left tail. So this is 1 minus a direct lookup. Okay. Good. So let's go ahead and look at the third kind of problem that we have, and that's going to be an area of a bounded region. So in the notes, we are looking for the area between two specified values. z equals minus 0.51 and 1.87. So let's draw the picture of the problem first. That's going to get us started. So here's my variable, my parameters, my delimiting values. So one of them is negative here. And we're looking for the area between the specified values. Okay, so this looks similar to the third kind of a problem that we can use to find an area on the z table of a standard normal variable. Okay, this is the problem. But the tool that we have only gives left tail areas. So we have to figure out how to get the specified region only by looking up left tails. So what we can do is we find the area to the left of 1.87. Right, and that's all of this, and it's too much by that strip to the left of negative 0.551. So we're going to do two direct lookups here and then subtract them. Okay, so if you can even think about this, if you were thinking about cutting out construction paper with a little scissor or something, that you're trying to get at this bounded region. And so first you're going to do this left tail. All you're allowed to do is cut left tails. And then you're going to cut this piece of it off. So it's two direct lookups and a subtraction. Let's go ahead and I'll just pause the video and you guys can go find those values. And I'll meet you back in just a sec. Okay, great. So I hope you found the value. So the area to the left of 1.87, that's 0.9693. And now we're going to look up the area to the left of negative 0.51, and that's 0.3050. So the area, the bounded region is going to be the difference, two direct lookups and subtract. So let's put that over here. And so the bounded region ends up having an area of 0.6643. And the way to do this in general, the strategy is two direct lookups and subtract. So we're always going to want a positive area, so you're going to subtract the bigger number from the smaller number, so the bigger area from the smaller area. So it's the rightmost minus the leftmost, the tail defined in that way. When you show me these problems, it's certainly enough to just include what's up here. But if it helps you to draw more pictures, then you can draw more pictures. All right. I will see you in the next video.